This is a question based on lens. So we have the question given as follows. A convex lens of focal length 25 centimeter. This convex lens is made of glass. Where the refractive index is 1.5. This lens is immersed in water. So refractive index of water with air is 4/3. The question says calculate the change in focal length of the lens. So we have a convex lens. We are given a convex lens in the question. And this convex lens has a certain focal length. So when the convex lens is placed in air, we have parallel rays coming in. They will pass through the focus. So this is the focus, this length is the focal length. So when placed in air, this focal length is 25 centimeters. Now the question asks that if we change this medium in which the lens is kept from air to water, what happens to the focal length? Now in this question, we will make use of the refraction formula from lens. So we have the formula given as follows for refraction from lens. So this is the formula for refraction from lens. This formula essentially comes from the formula for refraction from a single spherical surface, which we saw in the previous videos. So refraction from a single spherical surface is as follows. We saw this previously as well. So this was the formula that we saw. This is refraction from a single spherical surface having radius of curvature r. N2 is the refractive index of the second medium, the medium in which the ray enters after refraction. N1 is the first medium, the medium in which the ray is originally present. So it starts from medium 1, goes into medium 2, and refraction happens. So this is the sequence. Now if we apply this formula to the two surfaces of the lens, so the lens is having two surfaces, two spherical surfaces. This is the left one and this happens to be the right one. The left one essentially meaning the first spherical surface that the ray encounters, and the right surface is the second spherical surface where the refraction happens. So and these two surfaces can have different radii of curvature. So this is the left surface or the first surface and it will have radius of curvature r1. This is the right surface or the second surface having radius of curvature r2. So when we apply this refraction formula for single spherical surface on both these two surfaces, we arrive at this formula for refraction from lens. Now in this formula there are various terms over here. Let me just explain what these terms mean. R1 and R2 we saw are the radii of curvature of the two surfaces. F medium is the focal length of the lens when it is immersed in a given medium. If it is air, then it is just air, and for air we have this focal length given as 25 centimeters. If it is some other medium, then we will find out the focal length in that medium. This term out here, this N glass of with respect to medium is refractive index of glass. Glass is the material of this lens. So this lens is made of glass. So that's why we have refractive index of glass, and this glass lens is immersed in some medium. So this refractive index term out here is refractive index of the material of the lens with respect to the medium in which the lens is immersed. So now we have this formula. We will apply this formula to solve our question. So first, for the case of the medium being air, we have as follows. Then if we write for water, we have as follows. Dividing the two, we get the following. R1 and R2 are constants. They do not change with the medium. They are a property of the lens itself, of the geometry of the lens. So they are constants. They will not come into this division, this ratio. Now we are given that refractive index of glass with respect to air is 1.5. Also, we are given refractive index of water with respect to air, which is 4/3. So, from this, we can find out refractive index of glass with water. So, from this, refractive index of glass with respect to water is nothing but refractive index of glass with respect to air divided by refractive index of water with respect to air. This is from the definition of refractive indices, how we define refractive index. Now let us come back to this ratio. This can be written as now refractive index of glass with respect to water we found is this ratio. So this is refractive index of glass with respect to air over refractive index of water with respect to air, this minus 1. Further simplifying gives us what we want. We want the focal length in water. Now substituting the values, we will get the final answer. So focal length in air is 25 centimeters given to us. The refractive index of glass with respect to air is 1.5. Glass with air is 1.5. Water with air is 4/3. So this comes out to be equal to 25 centimeter times 0.5 divided by 1.5 is 3/2. So this makes it 3/2 over 4/3 minus 1, which is so we found out the focal length of the lens in water is going to be 100 centimeters. It has increased. So the change in focal length would be focal length in water minus focal length in air, which is 100 centimeters minus 25 centimeters, which is equal to 75 centimeters. So this was what we were supposed to find out. We were supposed to find out the change in focal length when we place the lens in water. So when the lens was in air, its focal length was 25 centimeters. When we immersed it in water, its focal length became 100 centimeters. So the change in focal length is 75 centimeters. This solves the question.